Okay, our next speaker is an activist who studied at the University of Turku since 2003, where he earned a bachelor's in science. And at the TZM European Meetup in Rotterdam in 2015, he gave a presentation about our civilization's environmental problems. Here to give a talk entitled Science Simplified, please welcome Teemu Koskimäki.
Thank you all. You don't know how insanely difficult it is to follow up after that. Good job, but I'll try. I don't have as much experience probably. May need my notes a little more, but I'll try to present my topic in a simple manner. Let me just get the slides up real quick. All right. Exciting. So first of all, I haven't studied since 2003. It was 2013, but that's fine. No worries. So, hello all, and I'm very delighted to be here. My talk is about science, and I try to, as I said, explain it through a story, through a storyline. And first of all, why is it important? Did you know that the word science, in one form or another, is mentioned over 200 times in TZM Defined? It is the 8th word of the book, in fact. And to understand the scientific way of thinking is of paramount importance in our activism and for building a more sustainable world. And I still notice that many people do not know what science really is, even within the movement, where it came from, and what is its role in building a more sustainable society. So let me take you on a journey through time to understand how science came to be, and to understand through its story how it developed, what kind of thinking is involved, how is it practiced, and how dangerously lost we seem to be with it in contemporary society. So imagine yourself living in England 400 years ago. You could have gotten your employment by being a pricker or a witch finder. For each girl or woman turned over for execution, you would have received a handsome bounty. You would have searched for devil's marks, scars or birthmarks that when pricked with a pin neither hurt nor bled. And these marks were often searched for in places where the male inquisitors wished to find them. It went truly grim. It was also nearly impossible to provide compelling alibis for the accused witches. The rules of the evidence had a special character. For example, in more than one case, a husband attested that his wife was asleep in his arms at the very moment she was accused of frolicking with the devil. But the archbishop patiently explained that the husbands could not imagine that their powers of perception could exceed Satan's powers of deception. To question the accusations of the church was to claim that the church was committing a great crime by burning witches. Those who raised such possibilities were thus attacking the church and committing a mortal sin. Critics of witch burning were often punished, and in some cases themselves burned. The inquisitors and torturers were doing God's work. They were saving souls. They were foiling demons. This depiction was written in the book The Demon-Haunted World, Science is a Candle in the Dark by Carl Sagan, and you will hear his words throughout this talk and probably through the rest of my life, to be honest. We can see how difficult it was for people at that time and place to really master skepticism and rational thought. What a scary and confusing world that must have been to live in. Demons were real, superstition rampant, and I'm afraid we aren't completely out of those murky woods yet. Despite the enormous advances in knowledge we live to witness. Neil deGrasse Tyson said just a few weeks ago that it seems to me that people have lost the ability to judge what is true and what is not, what is reliable, what is not reliable. he said that he does not remember from his life any time when people were standing in denial of what science was. Every minute you're in denial, he said, you're delaying the political solution that should have been established years ago. And Carl Sagan called this out more than 20 years ago. He said that in times of scarcity, during challenges to national self-esteem or nerve, when we agonize about our diminished cosmic place or purpose, or when fanaticism is bubbling up around us, then habits of thought, familiar from ages past, reach for the controls. The candle flame gutters, darkness gathers, the demons begin to stir. There are signs of confusion and misunderstandings in the modern times, in the zeitgeist which we are trying to influence, and hence it is extremely impossible to understand what brought us here. How is it possible that we have smartphones, long healthy lives, easy access to diverse nutrition? How can our experience of life be so distant from those who lived just 400 years ago? The history of how we got here is in a large part the history of science. It is integral to the human story. Science is all about understanding the world. The word science in itself comes from the Latin word scientia, meaning knowledge. And it is this multi-generational accumulation of knowledge that has created the modern world. So let me show you how it all started. The early natural philosophers of Greece got really close to science. They had embraced the skeptical mind and a naturalistic way of thinking. But their ideas about the world were still widely incorrect. It was only when the ideas of those great philosophers about astronomy, physics, about medicine and about alchemy, which preceded chemistry, were truly questioned by experimental means, when science is said to have started about 400 years ago. In the 17th century England, there was a group of new experimental philosophers who wanted to understand the world through reason, logic and experiment. And in the year 1660, they transformed their invisible college into the Royal Society. Their motto was, and still is, nullius in verba, take nobody's word for it. This was a start of a revolution. 4 years later, a strange star appeared in the night skies above Britain. Instead of accepting it as a sign of doom, 5 young men started asking questions. What was it? Where did it come from? And what could explain its trajectory? The thinking developed through a series of tangible and practical experiments and findings. Robert Hooke designed a microscope and wrote the first major publication of Royal Society called Micrographia about his literally unforeseen findings. Together with Robert Boyle, he built the first air pump, which they experimented with and found for the first time that air had physical properties. In one experiment, they placed a bird within a glass chamber and sucked out the air. They discovered that air was essential for life. They had found invisible worlds all around us that we could understand through experiment and reason. The question was, how far could the same thinking apply? Could the movements of planets and stars also be subject to hidden laws? Edmund Halley, Christopher Wren and Robert Hooke would regularly meet in London's coffee houses to discuss their ideas about the possible laws of nature. They imagined an invisible force that kept the planets and stars in their orbits. But for this idea of an invisible force to have any credibility, there needed to be solid proof. And mathematics, which is based on deductive logic, was the way to find an explanation for the data. Then another comet appeared in the night sky 20 years after the previous one, causing confusion among the experimental philosophers. Halley knew that they needed Isaac Newton and convinced him to start the research. After 3 years, possibly the greatest work ever published was published, Philosophiae Naturalis Principia Mathematica. It held for the first time the mathematical principles of motion and gravity that govern the universe. It was a paradigm shift in the way we understand the world like no other. Newton's laws allowed Halley to solve the puzzle of the second comet, and we used those same laws to put humans on the moon. This achievement showed that mathematics was key to all science, and together these 5 great men summoned science into being. By using this new skeptical and experimental approach, the next generation gave birth to a series of new equal geniuses whose findings again transformed the world. We learned how to master and replicate even the most extreme natural phenomena like lightning. We learned that moving magnets could create electrical currents, and that electronic wires produced magnetic fields. The first battery was invented by carefully studying and mimicking the structure of the mysterious electric torpedo fish. And electricity helped us to discover new elements. Spectacular science shows were held, especially here in London, to showcase the new findings to the curious public. All of this and much more that has defined the world we live in today came from this new experimental approach, a new way of thinking. Science created new opportunities, inspired the Enlightenment, and made the Industrial Revolution possible. In the 18th and 19th centuries, the two theories of basic science, electromagnetism and quantum mechanics, were used in a progressive series of steps to ultimately create the transistor. These developments were crucial for us to handle the overwhelming amount of data created by expanding population and commerce. Applied science created radio, television, and the computer based on these developments. To me, this magnificent history really culminated in the space launches. We had started the scientific revolution by looking at the heavens, and in the latter part of the 20th century we went there ourselves. This is something that captivates the imagination, reignites us with the wondrous possibilities that science can offer. And all this progress, the very world we see around us today, testifies that science is simply not the same as any other system of thought. It's not a system of belief. It uses skeptical scrutiny, skeptical inquiry and experiments. And the technology we now take for granted speaks and testifies how science has been able to master a true understanding about the world and about the laws of nature. Science works and it can be trusted. No other way of thinking, wishing, praying or feeling has ever given us any concrete evidence of its value in gaining a deeper understanding of reality than science. As we have seen, science started from something very practical. Direct observations of the natural world and its phenomena, concrete, easy to understand experiments, and the acceptance and explanation of the results. But the main goal has always been to find out what is true about the world, not accepting what authorities tell us, but observing ourselves. Achieving that goal isn't straightforward, however. Really, there are just 3 ways scientists, or any one of us, can try to claim truth: deduction, induction, and inference to the best explanation. Deduction means that we have some premises which force a conclusion, which is either true or not true. We have to have perfect knowledge about the premises, however, and usually we do not have perfect knowledge, and we have to make generalizations from the data we do have, from personal experience or from measurements. And this, in turn, is called induction. But we can't logically claim truth or absolute truth based on it. The conclusions are either strong or weak, depending on the quality of data we do have. Scientists have strict rules about the use of induction, and statistics plays a big part in this. The third way to find out things is called inference to the best explanation. For example, genes were just a hypothesis, a made-up explanation for the inheritance of some traits. They were called discrete units of inheritance in the 19th century. But the key is that such an explanation can produce predictions based on deduction, which we can then try to prove false by doing experiments. If scientists do not observe what the hypothesis predicts, Either the hypothesis or the experimental design is faulty. If scientists cannot get the experiment to work, they have to conclude that the hypothesis predicted something that wasn't there, and it must be abandoned. Hypotheses can be ruled out using this experimental method until you are left with some explanation that gives true predictions about the world. And this deductive approach of falsification attempts to prove ourselves false and wrong is what science is all about. We come up with something that makes sense, we see what it would logically entail, and we test that. Notice that scientists do not try to prove anything. There are plenty of examples in the history of science of theories which have had confirming results but have still been flawed. One example is the theory and the discovery of the wave-particle duality of light. It was preceded by wave theory, which was already confirmed experimentally, but decades worth of testing finally falsified it. If you seek proof, you will most likely stop as soon as you see the first thing that confirms your ideas. And if you only seek confirmation, you're not doing science, but pseudoscience. Scientific hypotheses are tested by repeated experiments and by multiple independent scientists, and those explanations that survive this scrutiny become eventually accepted as a consensus by the scientific community. Many such confirmed hypotheses, which we haven't been able to falsify, are then combined together to form what is called a theory. But do not confuse the word theory with the word hypothesis, as is often done in natural sciences. As it's often done, because in natural sciences at least, a theory is something strong, something that we can be sure of, like gravity. But we cannot claim absolute truth, even to our theories, such as gravity. Proving something with imperfect data is a logical impossibility, not just for scientists, but for all of us. So scientists have developed ways to measure confidence statistically, and they disdain from claiming absolute truth, as should any honest person. And this is one of the reasons why you cannot get a clear yes or no answer from a scientist. Claiming to know the truth is the same as saying that you don't know what you're talking about. Scientists look for approximate truth, the closest we can get to with some confidence. As Neil deGrasse Tyson put it, out of our scientific method comes emergent truth, and it does it better than anything else we've ever come up with as human beings. If new evidence shows that some accepted theory is false, at least in principle, a scientist should admit after critically examining the proof that they were wrong and be happy that they were corrected. This is one of the reasons for the success of science. Newton's theory of gravity was, in the end, after more than 200 years, falsified by Albert Einstein. And as always, Carl Sagan put it well, quote, "Valid criticism does you a favor. Some people consider science arrogant, especially when it purports to contradict beliefs of long standing, or when it introduces bizarre concepts that seem contradictory to common sense. Like an earthquake that rattles our faith in the very ground we're standing on, challenging our accustomed beliefs, shaking the doctrines we have grown up to rely upon, can be profoundly disturbing. Nevertheless, I maintain that science is part and parcel humility. Scientists do not seek to impose their needs or wants on nature, but instead humbly interrogate nature and take seriously what they find. We are aware that revered scientists have been wrong. We understand human imperfection. We insist on independent and, to the extent possible, quantitative verification of proposed tenets of belief. We are constantly prodding, challenging, seeking contradictions or small, persistent residual errors, proposing alternative explanations, encouraging heresy. We give our highest rewards to those who convincingly disprove our established beliefs." Unquote. Everyone uses the scientific method, sometimes unknowingly. Even babies know the scientific method. First you observe, then you form a hypothesis and perform an experiment and analyze the data. After which you report your findings and invite others to reproduce the experiment. That's really as simple as it is. And if you really think about it, you will find that this method is actually the only way we humans ever find out anything when it isn't random luck. Trial and error, seeing what works, combining bits of information, and copying others. This method can also be used in a pseudoscientific way, however, to arrive at false conclusions. And this is why the scientific manuscripts have to source all claims made and present detailed methods for how the conclusions were arrived at. The finished manuscript is then sent to peer-reviewed journals for expert evaluation, and this is the last step in the scientific process before the article is published, assuming it isn't turned down. The accepted article is published for other scientists to read, cite, and criticize, and this peer review process exists to weed out any remaining subjectivity, biases, or illogical conclusions that can remain despite the years of education and help for other researchers. This multi-level criticism and checking is what is expected by the scientific community. And this practice, although not perfect, does increase the quality of scientific articles enormously. And this is why peer review is demanded for. If you do not have some conclusions, if you have some conclusions or research that doesn't get through peer review in any of the available journals that offer it, then your idea is most likely false, or it lacks the convincing evidence required for trusting it. And if there isn't convincing evidence, then we should withhold judgment until the evidence is in. Really, it's okay to say, I don't know. It's a strength, and it's a large part of the scientific way of thinking. Science challenges us to question our accustomed beliefs. And as science develops at a quickening pace, its theories get more complex and difficult to understand, and so it slips away from people who haven't been educated to be interested. And so we find ourselves in the 21st century, where people do not know what to trust anymore. Not understanding gives space for making up your own rules, and because those rules can be more simple, they are easier to understand, and they can be used to support your existing beliefs. Often they also start to masquerade as scientific, enjoying the hard-earned authority and trustworthiness of science without internalizing its methods or conduct. And this rising pseudoscience causes even more confusion and makes it even harder for people to understand what is real. Opinions become truths, and facts start to alternate. People have become distant from science, and the misuse of it has led it to losing some of its credibility in the public eye. And as we've seen, demons have begun to stir. On the 22nd of April 2017, there was a global march for science, which was a response to the rising amounts of people who have been distanced from the methods and principles of science, who have now reached for the controls, just the way Sagan predicted. Our future may be at stake here. Science has alerted us of the perils we now face. It is an early warning system for our civilization. But society has been slow in responding to these alerts. The structures we have in place have vested interest for re-election or continued sales, and the learned self-interest drives them to fight these inconvenient truths and change. Maybe they even refuse to believe the warnings, as if it was a matter of belief. They claim that the truth is not fully established, that we are not 100% sure, as if absolute truth was even possible, not the least necessary. And industries are known to have even bought off scientists to produce and publish research which supports their vested interests. These scientists have testified their views as objectively skeptical, and they have lied, maybe even to themselves. Scientists are human and thus fallible, and the existence of interests which want to take advantage of this for their own gain is highly destructive and dangerous. But it's not science that is at fault, it is the economic system we use. Misinformation is rampant and easy to publish, even profitable. And commercials are full of psychological tricks that exploit the feelings and inclinations of people. They lie with superlatives, present misleading data, and get away with it. Sagan also wrote that the commercial culture is full of misdirections and evasions at the expense of the consumer. You're not supposed to ask, don't think, buy. I'm ashamed to admit that the knowledge and skills of some scientists have been bought off to be used for these commercial purposes. It eats away the trust other members of society have for scientists. How can they do this? The answer is that there exists a high reward for doing it in the current economic system and a pressure to make money to survive. I maintain that despite all the misuse, science has still given humanity much more good, and it is the only thing that is able to save our future. Sagan wrote that science thrives on, indeed requires, the free exchange of ideas. Its values are antithetical to secrecy. The culture and ethos of science are, and for a very good reason, collective, collaborative, and communicative. But, however, in the current socioeconomic system, the necessity for ensuring one's future earnings has created an incentive for some scientists not to share their data. And then there are those scientists who are trapped in businesses and have to abide their rules of silence and secrecy. Today, scientists are limited by the funds they get and are forced to publish or perish. This idea, and this is a toxic environment for science. A resource-based economy, advocated by TZM, would free scientists from this burden and ensure that science got all the resources it needs to create a future of abundance for all of us. Scientists would be free to share all their ideas and work together, cooperate in the way that science should work at its purest. In a resource-based economy, the structurally created vast inequality and the incentive for having an uneducated mass of people would be removed. Using the proved potential of automation and a new scientifically derived resource management system, the new incentive would be to encourage and invest resources to give everyone the highest education possible. This investment to create a potential of 7 billion geniuses would pay back in a way we cannot even imagine. Think of how many Newtons, Einsteins, Curies, and Hawkings we have already lost because of prevailing income inequality. We need a new context, a new social system with different structural incentives, which would free us to utilize the scientific findings for the betterment of all, not after decades of fighting with the establishment, but near instantaneously, utilizing a technical solution. Given the times we live today, it could be said that science needs a resource-based economy as fundamentally as a resource-based economy needs science. This natural law resource-based economy, or NLRBE, is, I think, a scientifically falsifiable concept. An experimental city can be built. And if that experiment doesn't work, we should analyze what went wrong and try again. And if it didn't work at all, we should move on to something else. To falsify TZM, one can point out logical inconsistencies in the train of thought we advocate, or in the societal critique we offer towards the current paradigm. Note, however, that since we are all working towards the common goal of sustainability, advocates and critics alike, it is also valuable to try and solve the inconsistencies when they are found. And I'm willing to be proven wrong. That is the scientific way. I do not care if it's an NLRBE, TZM or TVP or some other that gets it done. I just want to help create a better world because logically I cannot say that it's impossible to achieve. The future is too stochastic for anybody to predict that. Clearly the way we are doing things right now is not evidence-based and it must go. But let's not claim absolute understanding and be closed off to alternative hypotheses. When researching the topics we care about, it is equally important to seek evidence against as it is to seek evidence for RBE and other TZM ideas. And if there are easier ways of accomplishing our goals, we should study them. Personally, I'm not aspiring to be a researcher who says, I'm here to change the world and I'm going to do everything I can to make that happen. if someone said that to me, I would probably respond that it seems like you're going to do a lot of bad subjective science then. Feelings introduce bias, unfortunately. And this is why the logical approach of science, which doesn't care about your feelings, is often deemed cold. But really, I do not see it that way. I think science does produce strong feelings. Sagan even said that they were equal to spiritual feelings. But they are only after we have made the discoveries, when we contemplate about what they allow us to understand about the universe which we are a part of. Feelings are part of being human, and they are a part of science, but ideally only a posteriori, after the evidence. When I was a child, I remember we were walking somewhere with my parents during a cold winter evening. I noticed something bright in the sky and I looked up, and I remember that was the first time when I realized what space was. It was in all directions. It was pitch black with countless tiny bright spots. It was everywhere. It was infinite. I had a feeling of reverential wonder, and it felt like time stopped moving. I went really tiny, insignificant, and for a moment I was really afraid. But it was the truth, or as close to it as I could get with my limited ability to sense the electromagnetic spectrum. Later I saw the footage of space launches, and I remember I was in awe. You mean we can go there? We can, but it is only by using science. And the same applies to a resource-based economy. In Sagan's words, which apply to us both personally and societally, better the hard truth than the comforting fantasy. Thanks for having me.
Keep applauding, come on!
Yeah, sorry.
Okay.